All right, so everyone's attention. Tanner?
Yes, sir.
Everyone's attention. So with this one, it says the largest Ferris wheel currently in existence is in Yokohama, Japan. The wheel has a radius of 50 meters and a mass of 1.2 times 10 to the 6 kilograms. So I know I can get the I. When they give me the mass and the radius, that's the information I need to get the moment of inertia. So I know I can get it from that. Part A says what's the moment of inertia. Part B then says what's the angular acceleration of the Ferris wheel if a torque of 1.5 times 10 to the 9 Newton meters is applied. If I give you this on the test, I probably won't even have the part A question, but you'll have to do it in order to get the part B. So the first thing I want to do is if I want to solve for angular acceleration, remember my formula for torque is I alpha. So if I want the angular acceleration, I know I'm going to take the torque and divide it by the I. Now, I'll tell you, on the last test, the one that had the 3 parts, it was almost a guarantee that you would get the points for part C because all you had to do was take that and just show me torque divided by I, and whatever number you got for answer A, even if it was wrong, and whatever answer you got for B, even if it was wrong, if you took that number and divided by that, I gave you the points for part C, and almost everybody did get those points, except for I can only think of one person who rearranged this equation wrong. And they had I over T, I over tau, and so they didn't get any points on it. So it was like one person, I think, did that. Almost everybody else got the points for this one. So if you look at this, I already know the torque, so all I have to do is get the I, and then I'll be able to solve for this. So I first have to identify what type of object is this. A Ferris wheel would be like a what? What would a Ferris wheel? Does it say what they want it? What we're supposed to represent it as? A Ferris wheel. I guess we'll do it it's a little weird because a lot of times they'll say it's a disc or ring. You want to do it as a ring? All right, because I mean it's technically a ring. Okay, a wheel. You're right. If that's a wheel, so we'll say it is a ring, but we're sort of ignoring all the parts that get from the center to wherever when you ride a Ferris wheel and you're in the little, on the seat, there's something connecting it to the center.
No, it's just a wheel.
Does it say? But I know it says a wheel, but I will do it as a wheel.
That's its name, Ferris wheel.
Okay. Shh. So if I do it as a wheel, then my formula is the same thing as a ring. So the formula is mr squared. And I'll know this as soon as we get, because I gave the answer for part A, and I'll know if I'm right off the bat here. So mr squared, so the mass is 1.2 times 10 to the 6 kilograms, and now the radius is 50 meters. Be careful when you're doing these problems that maybe they're going to give you the diameter. They give you the diameter, remember to take half of it for the radius. So most of the time I think I give you the radius, but every once in a while you get the diameter and you want to make sure you note that and divide it by 2. So if I multiply those together, what do I get? Do I get 3.5 times 10 to the whatever? 10 to the 9th? Do I get it? Because if I do, then yes, they're treating the Ferris wheel as a ring, because a wheel would be like a ring. It's a very simplified way of referring to a Ferris wheel because it's not really a wheel. I mean, there's certainly mass. What? Is it exactly 3? Oh, 3.0? Okay, yeah. So 3.0 times 10 to the 9th. And what are our units for a moment of inertia? What are the units? Kilogram meters squared. And so now I just have to plug the numbers in here. So my alpha is going to be, the torque was given as 1.5 times 10 to the 9th Newton meters. and we're going to divide that by 3.0 times 10 to the 9th kilogram meters squared. So, I mean, I can do that in my head, right? Because the 10 to the 9ths cancel out, and that's a half. So it's going to be 0.5. And what are our units for angular acceleration? Radians per second squared.
You know what, David? I don't like your tone.
All right, and that's it.